Welcome learners to our STEM channel. In the previous lesson we discussed light, and we said light is a form of energy which travels from the source, where we said we have two sources, that is luminous sources and non-luminous sources, in form of rays and beams. A ray, we said, is a narrow stream of light, while beams are collection of rays. So in this lesson we are going to discuss reflection of light on plane mirrors. So here we are going to see how light interacts with matter, and what we are going to realize is that when light interacts with solids, liquids and gases, it gets reflected back, or it bounces back. So bouncing back of light when it interacts with matter is what we call reflection. So in this case, matter is very important for you to note that it's in three states: solid, liquid and gas. So some gases which are colored, you are only able to see them if they reflect light. Liquids like water, juice, you are able to see them because they reflect light. Solids like yourself, your pen, your phone, your TV, you are able to see them because they reflect light into your eyes. So in this case, we have a case on the board here or on the screen. If you have a source, this is the source of light, it's a torch, and it is shining light in a whiteboard, or to a whiteboard which is in the dark. Assume this whiteboard is in the dark. If there's no torch, you cannot be able to see that word whiteboard on the board. So if you shine this torch towards the whiteboard, the person standing in the room which is in the dark can be able to see the word whiteboard. And why does this happen? This happens when this source produces light, the board which is in solid state reflects the light back, or bounces the light back to the eye of this person. So now that we have seen that light gets reflected back when it interacts with matter, it's very important for us to note that the type of reflection, or the reflection, does not take place the same way in all particles. So this means if you have different nature of particles in terms of roughness or smoothness, then the type of reflection that you will witness is different. Like in this case, in the first diagram, light, which we have three rays, this is the first ray, second ray and the third ray, they are parallel to each other. When they hit this smooth surface in the first diagram, they get reflected parallel to each other and in the same direction. So when light interacts with a smooth surface, it produces what we call a regular reflection. And we define regular reflection as a type of reflection when parallel incident rays are reflected parallel to each other when the reflecting surface is smooth. And this is the one which we will be interested throughout the reflection on plane mirrors and also in curved mirrors. Now, when light interacts with a rough surface, like in the second diagram here, where you have parallel incident rays, but when they hit a rough surface, they get reflected in different directions. Like you can see the first ray in the second diagram, second ray, and then the third ray, they are moving totally in different directions. And in this case, they produce what we call irregular or diffuse reflection. And we define this one as a type of reflection in which parallel incident rays are reflected in different directions or for a rough surface. So for you to have irregular reflection, then in this case you must have a rough surface. But if you have a smooth surface, then it means you are going to have what we call a regular reflection. And that's why the mirrors we have at home, the side mirrors, are made with a very smooth surface so that they can produce what we call regular reflection, which can form an image which you can see and interpret correctly. So before we can move to the laws that govern reflection, it's very important for us to discuss the terms associated with reflection. So the first term that we can discuss here is the incident ray. And an incident ray, we define it as a ray from the source to the smooth surface. A ray which moves from the source to the reflecting surface. Like in this case, we can see the source up here. So this ray which moves to the reflecting surface is what we call the incident ray. Then the second term that we can define is what we call reflected ray, and we define it as a ray that bounces back from the mirror. So in this case, if we have a mirror here, then the ray which has moved out, this is what we can call ray 2. If this one is ray 1, this ray 2 is what we call a reflected ray. Then another term is a normal line, and a normal line is defined as a line which is imaginary and it's 90 degrees to the reflecting surface. Like in this case, you can see this line which we call a normal line. So this line is 90 degrees to the mirror, and it has its own importance, which we are going to see shortly. Then another term is angle of incidence, which we call I. This I here is what we call an angle of incidence, and we define it as an angle between the incident ray and the normal. Mark this one, an angle between the incident ray and the normal. Let's go to the incident ray. The incident ray is here, ray 1. So if we measure this angle to the normal like that, this is what we call the angle of incidence. Then another term is angle of reflection. This is an angle between the reflected ray and the normal. Mark also this one. This is an angle from the reflected ray to the normal. So if we go to the reflected ray, this one ray 2 here, we move to the normal, then this is what we call the angle of reflection. So these angles are measured from the ray to the normal and not from the ray to the smooth surface. They are measured from the ray to the normal. Very important. Now the last term that we can discuss is a point of incidence. A point of incidence is defined as a point on the mirror in which the incident ray strikes the reflecting surface. So for you to have a point of incidence, then you have to mark the point where this incident ray, ray 1, this one here, where this ray strikes the surface. That is where, or that is the point we call the point of incidence. So now that we have looked at the terms associated with reflection, it's very important now to look at the laws that govern reflection. So the first law states that the incident ray is this one, incident ray, a ray from the source to the reflecting surface. The reflected ray, this is what we call a reflected ray, a ray that bounces back after the reflection, and the normal line, normal line, a line which is 90 degrees to the reflecting surface. This is the reflecting surface. So the law states that the incident ray, the reflected ray, and the normal line all lie in the same plane at the point of incidence. This is what we call a point of incidence. This one here, point of incidence. So the law states that the incident ray, the reflected ray, and the normal line all lie in the same plane. They lie at this same plane at the point of incidence. So that is the first law of reflection. The second law of reflection states that the angle of incidence, this is what we call an angle of incidence. This one, angle of incidence, and the angle of reflection are equal. This is what we call an angle of reflection. So the second law states that the angle of incidence is equal to the angle of reflection. So whenever you are doing your reflection at any point, you must be able to observe these two important laws. The first one states that the incident ray, the reflected ray, and the normal line all lie in the same plane at the point of incidence. And then the second law states that the angle of incidence is equal to the angle of reflection. Let's now look at how images are formed behind the mirror. So in this case, these plane mirrors, we define them. We define a plane mirror as a mirror which is flat and smooth. This is different from curved mirrors because we want to define curved mirrors as a mirror which is curved and smooth. So in this case, before we can form images behind the mirror, then it's very important for us to note on these 2 points. The first point is that the object and the image are in the same line and 90 degrees to the mirror. 90 degrees to the mirror. Another important thing that we should note is that a ray which is 90 degrees to the mirror will get reflected along its own path. So if you have a ray, like in this case, if we have a ray here, and if it's 90 degrees to this mirror, after getting reflected, it will move along its own line. So that's what we mean in this second point. So in this case now we have an object here. We have an object and then we have an image. I want us to draw rays on how a person who is here. This is the first person. This is the eye one. I also want to draw an array on how a person who is here. This is the second eye up here. Someone who is here. And also someone who is down here. This is another eye. This is the first eye, second eye up there, third eye down here. How will these people see that image? Remember, we have an image behind there. So in this case, before we can also move, let's remember that behind the mirror, behind the mirror, rays are virtual. Rays are virtual. Virtual rays are drawn using dots. Also, the image is virtual. So the image cannot be drawn using a complete line. It should also be drawn using dots. Like you can see here, I've not drawn a complete circle for this image. So now let's form that image for these three eyes. The person who is at the middle here will see this image, or we see the image of this object when this light moves from the object to the mirror, and then the same light gets reflected back. Now when it gets reflected back, it will move straight into the eye. Let me use a different ink. It will move back to the eye of this person like that. But this person will see the image of this object as if light was coming from behind this mirror. So it will see as if the light was coming from that image like that. So in this case, this person will see that object and the image in the same line. Now, if we have an eye at the top there, this second eye up here, this person will see as if light is coming directly from the image. So in this case, we will draw a straight line to the mirror like that. Then behind the mirror, we will draw dotted line. But now, does light come from that image? No, the light came from this object. So we will join that line, that ray, from the mirror to the eye. So this light came from the object to the mirror, and then from the mirror to the eye. So that person will see it like that. And then the person 3, who is down here, will also see the image as if it's coming, or the ray is coming from behind the mirror where the image is. So in this case, if I use a red ink here, this ray could have come into this eye like that, but this person will see as if this ray was coming from behind the mirror like that. But in real sense, this ray had come from the object. The ray had come from the object to the mirror, and then now from the mirror to the eye. So that is the reality. But this person will see as if the image is coming from behind the mirror. So in this case now, we have fulfilled what we have just said here. The object and the image are in the same line. So as you can see, this object here and the image behind, they are in the same line. And then another thing, and they are 90 degrees to the mirror. If you draw a line from the object to the image, they are 90 degrees to the mirror. But again, a ray which is 90 degrees to the mirror will get reflected along its own path. You can see that the person A will see the image and the object are in the same line. So it means that ray traveled along its own path. Then another thing that you have seen is that rays behind the mirror are virtual and they are drawn using dots. So this is what we call a virtual ray. And this image which is drawn using dots is also called a virtual image. We have looked at how to form images behind the mirror. It's very important for us to look at or to try to locate the image behind the mirror on these two setups. So in this case, what we are going to do, we have setup 1 and setup 2. We can call this one setup 1 and then this one setup 2. So if we want to locate this setup 1 inside the mirror, then we have to identify the point where we are going to get our rays from. So we are going to get the rays from A, we can get ray from C, we can get a ray from Q and even B. So when we are getting them, we are going to draw them 90 degrees like that, and then same distance behind the mirror. But in this case, we said rays behind the mirror are drawn as virtual rays. So this is B prime. Then if you want to locate C, then in front here, continuous line, then behind dotted line for virtual rays, same distance behind the mirror. This is our C prime. Then down here you have A, continuous line in front of the mirror, dotted behind the mirror, same distance. Then this one is going to be our A prime. Then you come down here for Q, you draw a continuous line to the mirror, then a dotted line behind the mirror, then same distance behind the mirror. In this case, you have your Q prime. So in this case, since in front here we are talking of rays, they must have direction, and since they are 90 degrees to the surface, then they get reflected along its own path. So in this case, that's how our rays are going to look like. Then now what's remaining is to join the points. Q is going to join with C like this. Q and C will join like that. Then B is going to join to A through C. So you join this like that. So in this case, you have formed your image. That is your image. So there is something unique that has emerged here. This point A on the screen, it's in the left side on the object, but on the image, it has turned to be on the right side. B on the object is in the right side. Then in the mirror, B is in the left side. What happens? We are going to call that a lateral inversion in the next part. But now, our interest here is to form images. Let's form the image on diagram 2. In this case, you have an eye here, you have an object here, then now you have a mirror. You are required to form the image behind the mirror, and then you use the same rays to determine how this eye will see that image. So in this case, the first thing that we do, we locate where the image will be formed. We have said the image will be formed behind the mirror and same distance as the object is in front of the mirror. So in this case, for us to locate the image, then we have to draw a line which is 90 degrees to the mirror, 90 degrees to the mirror, and then same distance behind the mirror. So in this case, this line is 90 degrees to the mirror, and then same distance behind the mirror. Then now our image is going to look like that. And since images are virtual, then we don't use continuous line. So that is how our image will be formed, or that's the place where the image will be formed. We can even name this one an image. Let's name or label this one as an image. Then now, how will this eye see that image? We use the first statement that we used in the previous lesson or at the beginning of this video. We see objects when light from the object reaches our eye. Can you see the object in this case or the image? The person is going to see the image inside the mirror. So in this case, you will draw a straight line because light travels in a straight line. So this person will see that image like light is coming from that image in a straight line. So this light behind the mirror is virtual. We draw dotted lines. Then in front here, we draw a continuous line. Then also from the base of this image, dotted line. Then in front of the mirror, continuous line. Now this light is coming into the eye. But now the question is, does this light really come from the image? No, this light came from the object and get reflected from the mirror into the eye. So we have now to connect a ray which is coming from below the image. This ray will get connected to the ray coming from below the object. The one coming from the top of the image here will get connected to the one coming from the top of the object. So in this case now, this ray came from the object to the mirror, following the laws of reflection, and then bounced back to the eye. That's how this person is able to see the image behind the mirror. Here we have observed several things, that the object and the image are in the same line, 90 degrees to the mirror, and then the image is virtual, and then again, rays behind the mirror are virtual. These are virtual rays. Virtual rays. Another thing that you should note is that the size of the image is the same as the size of the object. We are going to see some of these properties, but I'm mentioning them prior to that. So now you found that interesting. Let's now enjoy doing this one. But in this case now we are given an image. We are required to locate the object. Remember in the previous one, we were given the object and we were supposed to locate the image. Now we are supposed to locate the object and then show how this eye will see that image. So in this case, before you draw the rays, the first thing that you do, you locate the position of the object, and you use the idea that the object is in the same line with the image. So in this case, if the object and the image are in the same line and the same distance behind the mirror, then now here we can locate our object very easily. 90 degrees to the mirror and then same distance behind the mirror or in front of the mirror now. Same distance in front of the mirror, 90 degrees. So here it is 90. Same distance in front of the mirror. Then this image, the upper part, will also form 90 degrees. 90 degrees to the mirror. Then same distance in front of the mirror. Like that. So here it's 90. Then same distance in front of the mirror. And now since this one is an object, then now we draw it with a continuous line and a ball like that. So this is now the position of the object. Now the question is, how will this eye see that image inside the mirror? We have said for you to see that image, light must travel virtually from the image to your eye. So you place the ruler on the eye of the person and the upper part of the object of the image. You draw a continuous line in front, then dotted line behind the mirror like that. So this ray came to the eye of this person. You show using an arrow. Then below the image, you draw dotted line behind the mirror, continuous line in front of the mirror. This light came to the eye of this person. But did this light really come from behind the mirror? No. the light came from the front part of the mirror where we have our object. So you connect the ray which is from below the image to a ray or to the below the object, like that. So this ray from below the object came like that, bounced back into the eye. Also the ray at the top here, you connect it to the ray which is coming from the top of the image. So in this case, light came from the object like that and then get reflected back to the eye in that case, but the person will see as if the image or the light is coming from behind the mirror. So in this case, we have, these are real rays. These are virtual rays. Virtual rays. And this image is a virtual image. A virtual image is an image which is formed behind the mirror or formed by virtual rays. We are going to define it like that. So now let's look at the characteristics of the images formed by plane mirrors. And in this case, this is a very important concept which is going to wind up the plane mirror part. So as we move to curved surfaces, we are also required to state the properties of the image or the characteristics of the images formed by mirrors. So in this case, we're going to use this letter T drawn on the screen. We have Q there and Q prime. So in this case, the first property is that all images formed by plane mirrors are erect. Erect in this case, it means the image is upright. The object, if the object is upright, the image is also upright. That's why you see AB at the top. Also in the image, AB are also at the top. Q is below. In the image, Q prime is below. That is the first characteristic. Then the second characteristic is that the image is the same distance behind the mirror as the object is in front of the mirror. This distance here, we call it V, is the same as the distance here, which we call U. U is the object distance, V is the image distance. This image distance is always equal to the object distance in plane mirrors. But we are going to see when it comes to curved mirrors, the image distance and object distance might differ. Then the third property or characteristic of the image is that the image is virtual. The image, this image is virtual. I've mentioned this word several times. A virtual image, it means it's an image which cannot be formed, an image that cannot be formed on the screen, an image that cannot be formed on the screen, or an image that is formed by virtual rays, an image formed by virtual rays. That's what we call a virtual image. So you can see the image is drawn using dotted lines. It means it's an image which you cannot touch. You cannot touch your image inside the mirror. That's what we call a virtual image. Then another property is that the image is laterally inverted. A lateral inversion is a scenario where, that I mentioned, you raise your right hand and then you see your left hand raising up. When you raise your right hand, you see your left hand rising up. That's what we call a lateral inversion. And I want you to note it on this diagram. Look at the screen. We have A, it's on the left side of the screen. But in the image, A is on the right side. We have B, it's on the right side of the screen in the object. But inside the image, B is on the left side. So that's what we call lateral inversion, where left looks like right and right looks like left. Then finally, we have that another characteristic is that the image is the same size as the object. So if you look at this, the image and the object, they are identical in size. They are of the same size. So now that you have got all the concepts of light and how light can be reflected and all the laws of reflection and how to form images in plane mirrors, now we can move to the next lesson, reflection at curved surfaces, where we will discuss concave mirrors, convex mirrors. See you then.